Well, hello and welcome to today's video. We're going to continue on with linear equations. We're going to focus on vertical and horizontal lines today, and then when lines are parallel or perpendicular. So when you look at number 11, hopefully you realize that that is a vertical line, and vertical lines are not functions. So they are something that we don't talk about a lot because, again, we like focusing on just the functions. But what we're wanting to do here is actually write an equation for all vertical lines, just to give you a general form. So when you look at this vertical line, I think the easiest thing is just to look at some points that are on this line. So we're just going to look at some points. So the bottom point there would be 3, 0. The next point would be 3, 1. The next point is 3, 2. And if I had a point down here somewhere, it would be 3, what is that, -5. So one of the things that you notice on a vertical line is that in this case, x equals 3. Well, that is the basic form of a vertical line. It is actually x equals some number k, and it will always be that way. So x equals some number k is our equation for our vertical line. And the other thing too, when you look at slope on here, if you did the slope formula, okay, and we have, I'm just going to take the first 2 points up here. We'll just take the first two. They're pretty easy. And I do a change in y over a change in x. One of the things you're going to notice all the time is that your denominator is 0, and we cannot divide by 0. So all vertical lines have an undefined slope. Okay, undefined slope. So those are the key things that you need to remember here with vertical lines. They're not functions. Your equation is always going to be x equals some number, and they have an undefined slope. Now, horizontal lines, if you look at it, and again, if we kind of do that same thing that I just did, this would be the point 0, 1. The next point would be 1, 1. The next point would be 2, 1. Lost my train of thought there for a second. 2, 1, and then so forth. Again, if I come over here and I choose a point, it might be -4, 1. And so in each of these cases, what we're seeing is that your y equals 1. And if we did a slope, when I do, and Leslie, I'm going to use these 2 points, and when I do a change in y over a change in x, I'm going to get 0 over some number. So my slope is 0. So the things that we need to remember about horizontal lines, okay, is that they have a slope of 0, and their basic equation will be y equals k. Now, this one we could also, since it is a slope of 0, you could also say y equals 0, x on there, plus, in this case, your k will be your intercept. But it's easier, I think, just to remember y equals k. So you could actually remember it either way, okay, putting into slope-intercept form that we just talked about in the last video. Okay, parallel versus perpendicular. Well, first off, hopefully you remember what parallel lines are. 2 lines in the same plane that never intersect. Well, the only way that that can happen is if those 2 lines have the same slope. So the slope of parallel lines are the same or equal. So if one has a slope of 2, the other's going to have a slope of 2. Then when you do perpendicular lines, again, I'm going to draw it at an angle. I I think it sometimes helps, perpendicular lines. On that, if you'll notice, this one has a slope that is positive, this one has a slope that is negative. And so when we talk about the slope of perpendicular lines, we say that their slopes are negative reciprocals. So what I mean by that is if one has a slope of 2/3, the one that is perpendicular to it will be a negative 3/2. Okay, now I do use a lot in here. I don't like writing out parallel and perpendicular, so I will do the parallel symbol and the perpendicular symbol. So like over here where I did M perpendicular, that's saying the perpendicular slope would be negative 3/2. Okay, so again, hopefully that is a review, not new material. So let's go ahead and look at the directions here. It says determine whether the lines are parallel, perpendicular, or neither. And so in order to do this, we probably need to put both of them in slope-intercept form. That would probably be the easiest way. So I'm going to start with the first one here, and I'm going to put it in slope-intercept form. Remember, y equals mx plus b. So I am going to move my 10x over. And again, I'm solving for y. So y equals a negative 2x plus 1. So in this case, this one has a slope of a negative 2. So I'm going to do the same thing to the next one. And in this case, the y is already over on this side, so I'm just going to move my x over. So I have a negative x minus 16 equals 2y. I'm going to go ahead and divide by 2. So negative 1/2 x plus 8 equals y. And again, I could flip that around to get it in full slope-intercept form, but really all I need is my slope. Okay, and so in this case, when I look at this, I have one of them has a slope of a negative 2, the other a negative 1/2, and so my question is, are they the same, or are they negative reciprocals, or are they neither? And they're definitely not the same. They're not negative reciprocal because they're both the same. So in this case, this would be neither. Oops. Okay. Let's try another one here. So I'm going to do the same thing. So I'm going to run through it real quick. And I'm going to reduce my slope down, so that will go to 4/3, and that would be minus 7. So now I'm looking at, again, my slope. It's 4/3. On the next one, it's already got the x on the other side. The y is by itself, but I do need to go ahead and get that, so it's y equals. So in this case, I now have y equals a negative 3 plus 4/3 x. And again, if I rearrange it just a little bit to get it in slope-intercept form, my slope is 4/3. So in this case, they are the same, so these lines would be parallel. Okay. Okay, so that is your introduction to horizontal and vertical lines. Again, we will come in and finish those up together and talk about them later.